Okay, you guys, now we're going to start the remainder and factor theorems. Now, this is going to give us some clever little ways to apply the synthetic division we learned from last lesson, which is great. That synthetic division really helps a lot. So anyways, here's what we're going to do. The first problem, well, these are the type of problems we're going to do. I'm going to show you how to do 3 different types of problems. So follow along with these and I'll tell you which ones out of the homework that they correspond to. For instance, let me show you the first one. Okay, see where it says 375, 1 through 8? That means that it's page 375 is our homework. This is like problems 1 through 8 on the homework. They want you to use synthetic substitution to find this. Given that the polynomial p of x is x to the fourth minus 14x squared plus 5x minus 3, given that polynomial, find p of -4. That's what they're telling you to do. Okay, it's all right, I'll fix it. So the deal is find p of -4. So how would you do that? Well, let's go over here. I've got the same problem written right here. It's the same thing I just showed you. P of x is x to the fourth minus 14x squared plus 5x minus 3. Okay, find p of -4. Now, if I ask you how to do that, you should already know how to do that, actually. You should know that all you would have to do is take -4, plug it in for x, and crank it out. And if you do that, you should get the correct answer. That's how I would expect that you would do it right now. But I'm going to show you another way of doing it that gives you the same answer as if you were to take -4 and plug it in for x. And that is this. First of all, you take this number as the root, p of -4. So you take -4 as the root, and you do synthetic division on this polynomial. Just like you're dividing this polynomial by x plus 4, right? Now, you might be thinking, wait a minute, don't I change the sign? Remember, when we were doing synthetic division, we changed the sign on the thing we're dividing by. But here's the deal. If I said, what is this guy divided by x plus 4, then you would say, what is the root that goes with x plus 4 as a factor? It would be -4, because that's the x value that it would take to make that equal 0. So you have to change the sign, -4, right? But if I give it to you as the root, what is p of -4? I'm already giving you -4 as the root. I'm not giving you the factor and saying, what is the root that goes with it? I'm already giving you the root. So you do not need to change the sign. You use, if this is the -4, you use -4 in the root here, okay? So, and then you just put all the coefficients without the variables. Remember though, look, 1x to the fourth, there's no x to the third power here. Very important. You gotta account for every power. If there's no x to the third, you gotta put a 0. If you don't put a 0 there, you will get the wrong answer. Make sure you put the 0 there. Okay. Minus 14 there, plus 5, minus 3. And we're just gonna do regular synthetic division like we learned last time on this. Here's how you do it. You bring this guy down under the line, whatever the number is here, multiply. This times this is -4, add -4, multiply 16, add 2, multiply -8, add, you get -3, multiply, you get regular 12, -3 and 12 is 9. So if this were regular synthetic division, we'd have the remainder, constant, first power, second power, third power. You could get the polynomial of this guy divided by x plus 4. But that's not what we're doing here, actually. What we're doing here is, if you're trying to find out what is p of -4 by using synthetic substitution, all you have to do is look at the answer. The answer is the answer. So p of -4 is 9, right? Whatever the remainder happens to be is the exact same thing you would get if you'd plug this in and crank it out. It seems like magic, but that's how it works every time. If you do it correct, it'll work that way every time. So what do you do with this? Nothing. You just throw it away. All right. So next problem. Same exact problem, basically. I mean, different numbers, same exact idea, same exact instructions. Look, it's just like page 375, numbers 1 through 8, the problems you're going to be doing on the homework. Given this polynomial right here, 2x to the fifth minus 8x squared minus 5x minus 3, use synthetic substitution to find p of 2. So that means I'm going to do synthetic division with 2 as my root. So here's 2, and I'm going to put the coefficients. So 2x to the fifth. Uh-oh, there's not an x to the fourth. Put a 0. Wait a minute. There's not an x to the third. Wait a minute. Does that mean I need 2 zeros? Yes, it does. What if I only put 1 0? I'll get the wrong answer. Don't do that, right? It matters. 2 missing powers, the fourth and the third, you need 2 zeros, okay? Then we got minus 8, then you got minus 5, then you got minus 3. And we're going to do synthetic division. And when we do synthetic division, blah, 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 whatever, this will be the answer we're looking for, right? This is it. All the rest of this is just garbage. Okay, so here we go. Bring this guy down. Multiply, 4, add, 0 and 4 is 4. Multiply, 8, add together, 8. 8 times 2 is 16 right here. Add those together, 8. Multiply, 16. Negative 5 and 16 is 11. 11 and 2 is 22, baby! You know it! You know it. 22. Right. And this is 19. Cha-ching, cha-ching. I told you guys. Oh my gosh. Isn't this great? I love it. Ugh. Okay. So that's like problems 1 through 8 on the homework. Okay. Now, problems 9 through 16 on the homework are going to be like this. Different. 9 through 16. Okay. It seems similar. It's going to be very similar, but here's the deal. Is x plus 1 a factor of this guy? Now, we did stuff like that. It is, we did division of that. What does it mean to be a factor? It means it divides evenly. For instance, like 20 is 5 times 4, right? Because 5 times 4 is 20. So 20 factors into 5 times 4 because these two things multiply to be 20. Right? So that's the thing. Because 4 goes into 20 evenly. 5 goes into 20 evenly. The question is, does this polynomial go into this polynomial evenly without a remainder? That's the big question, okay? So you could do it. This is one way of doing it that we're not going to do, but this is one way you could do it. You could do it by synthetic division and find out, do I get 0 as a remainder right here? If I did this synthetic division and got 0 for a remainder, that would mean that goes into that evenly without a remainder, so it is a factor. If I get anything other than 0, like 19 or 9 or something like that, if I get anything other than 0, then it is not a factor because there's a remainder and it does not go evenly. Okay, so that's what I could do. Here's the problem with doing synthetic division. Now, if you're taking notes, do not write this down because you're going to find out that I'm just going to erase it because this is not how I'm going to do this problem. But I'm going to show you what would happen. We could do this by synthetic division. It is possible to do this problem by synthetic division. Okay. First thing you do is you say, what's the factor that goes with x plus 1 as a root? Well, it's going to be -1. Remember, you got to change the sign. -1. Here's the problem with doing synthetic division on this. You'd have to go, okay, it's 1x to the 12th, right? Right. Is there an x to the 11th? No. How about 10? No. How about 9? No. Is there an 8th power? Yeah, -3. How about a 7? No. How about 6? No. How about 5? No. How about 4? No. How about 3? No. How about 2? No. How about 1? Yes, -4. What about constant? So I would have to do that synthetic division right there, which is okay. I mean, it's not that bad, but look at all those zeros and everything. There is an easier way to do it, right? I would not recommend synthetic division. When these powers get high, I would not use synthetic division because you have to account for all the missing zeros, okay? Well, I told you we weren't going to do it that way, so I'm going to erase this. If you wrote it down, I would erase it or scratch it out because that is not how we want to do this. I'll tell you how we want to do this. The other option is, wait a minute, what is p of, okay, the root that goes with this again would be -1. What is p of -1? Well, I could find it by synthetic division. It would be the remainder. Now, if it's a factor, that means that remainder would equal 0. So if p of -1 equals 0, that means it would be a factor. If it's anything other than 0, it's not a factor. Well, the other way is the old-fashioned way of doing this. I could do it by just plugging it in. I could plug -1 in for x and see if I get 0 for an answer there. So here we go. -1 to the 12th minus 3 times -1 to the 8th minus 4 times -1 minus 2. That's what I get when I plug -1 in for x. Notice, the nice thing about this is I don't have to account for the missing terms with zeros. So look, makes it less than all that synthetic division would have been. So what do I get here? -1 to the 12th. A negative raised to an even power wipes out the negative, so it's just regular 1. 1 to the 12th is 1. -1 to the 8th is going to again be positive 1. Then I times by -3, it's going to be -3. -4 times -1 is +4. And then -2. Okay, let's see what that equals. 1 minus 3 is -2. +4 is regular 2. -2 is, oh my gosh! Oh my gosh! Can you believe it? 0. Cha-ching, cha-ching. Oh my gosh! Oh my gosh! You know what I would say the answer is? C. Es un factor. Okay. Or for all of you monolingual guys, yes, it's a factor. Get it? Nice. Cha-ching. Because this was 0. If it's 0, that means that goes evenly, no remainder. Because remember, what you get when you plug this -1 and crank it out is the same thing you would get if you did synthetic division and ended up with a remainder of 0. So there you go. Now, this problem, exactly the same idea, okay? Is x minus square root 5 a factor of this polynomial? Okay, well, let's look at this now. X minus square root 5. What would x have to be to make that equal 0? How about positive square root 5? Look, square root 5 minus square root 5 would be 0. So the root that would go with x minus root 5 is just regular root 5. So I can either do root 5 and do synthetic division, but again, that's not what this was telling us. In problems 9 through 16, they're not telling you to do it by synthetic division. They're telling you to do it by plugging it in. That's how they want you to do. That's what the factor theorem means. You're doing it by plugging them in. Okay, so I'm going to say, what is p of root 5, right? I'm just plugging it in. It's going to be square root 5 to the 4th minus 3 times square root 5 to the 3rd minus 4 times square root 5 squared minus 2. Okay, let's see what that is. That's going to be, what is square root 5 to the 4th? Notice, it's root 5 times root 5 times root 5 times root 5. That's what square root 5 to the 4th is, right? 4 of them multiplied out. Well, look, square root 5 times square root 5 is just 5. This square root 5 times square root 5 is 5. 5 times 5 is 25. This guy is 25. Okay. Now, what is, let me do this one in a different color. What is 3 times root 5 to the 3rd? Well, let's see what root 5 to the 3rd looks like. And then we're timesing it by 3, so it'll just be minus 3 times that. Well, let's see. That's going to be minus, watch this. This is, actually, let's don't do it that way. Let's do these two. These two, root 5 times root 5 is just 5. It's 3 times 5 times square root 5, which is 3 times 5, 15. 15 root 5. That's what we get so far. Now we still got these guys to go. Okay, so let's see, what is minus 4x squared going to be? Minus 4 times root 5 times root 5. Now, these guys are 5, right? Root 5 times root 5 just turns out to be 5. So it's 4 times 5 is 20. So it's minus 20. Put that right here, minus 20. And then finally, minus 2. Let's see what this turns out to be. 25 take away 20 is 5. Take away 2 is 3. And this is this, so I get 3 minus 15 root 5. It's supposed to be 5, not 15.
That's what I thought.
Yeah. It's root 5 like that. Sorry. Now, whoa, that's an ugly answer. Doesn't matter. Doesn't matter if it's ugly. Doesn't matter if it's pretty. What matters is that 0 or is that not 0? Looks to me like it's not 0. So that means, is this guy a factor? No. No es un factor. Or for you English only speaking people, no. All right. Here we go. Okay. So, all of those guys. Kind of fun. That's 2 out of the 3 things we're going to learn today. The least fun ones. Actually, now we get to learn the funnest one of all. The funnest type of all. Okay, the more useful kind, I think. We'll get over to them. They're going to be stuff like that. Solving equations. We're actually going to be solving equations. Can you believe it? So it's going to be like problems 17 through 20 on your homework. They're like this. What happens, notice what that is. They're giving you a polynomial. In this case, it's a 3rd degree, x to the 3rd power. And that thing, they're giving you a root of that polynomial. They're telling you the polynomial x to the 3rd plus x plus 10 equals 0. That polynomial has a root of -2. -2 is a root of that polynomial. It's not like -2 might be a root of that polynomial. They're telling you -2 is a root of the polynomial. That means that I could do synthetic division on that polynomial with -2 as a root, and I should end up getting a remainder of, what would you think? If it's a root, and I do synthetic division on this polynomial, and it's a root, what should my remainder be? Okay. Hopefully you answered 0, because that's the deal. If the thing is a factor, then your remainder would be 0. So here's the deal. So let's do synthetic division with our root of -2 on this polynomial. Because it's a root, it should go evenly. Let's see, -2, and I get 1x to the 3rd. There's no x squared term, so 0. Don't forget the 0. If you don't put in the 0, you'll be in trouble. There's a 1, there's a 10. Now, because they told me it's a root, then guess what? Guess what I'm expecting this to be? 0. If this isn't 0, there's a problem. One of 2 things happened if that's not a 0. Either I screwed up, or they're dirty, filthy, stinking, rotten liars, right? Let's hope they're not liars, and let's hope we didn't screw it up. Let's hope we do get a 0 there. That's what I'm expecting. Let's see. Bring down the 1. Multiply. Here we go. Add. -2. Multiply. 4. 4 and 1 is 5. This and this is -10. This and this 0. Cha-ching! Cha-ching! It's not like, yeah. I'm going to go buy a lottery ticket. No, if it didn't turn out to be 0, there'd be a problem, because it's supposed to be a root. It should give you 0 remainder. But here's the good news, because we don't know how to solve a general 3rd degree equation. We only know how to solve 2nd degree equations by either we could do completing the square, or factoring, or quadratic formula. So here's the deal. So now we've got it down to remainder, constant, first power, second power. When you do synthetic division on a root, you knock it down a power. You knock it down from third degree, in this case, down to second degree. Here is the polynomial that's left over. X squared minus 2x plus 5. That guy equals 0. The other two roots are hiding inside of that guy. A third degree equation is going to have 3 roots, right? So one of them is -2. The other two, see what we did is we sucked that -2 out of this polynomial and knocked it down by a degree. That's what we did. We knew this was a root. We sucked it out of that polynomial, knocked it down by a degree. Now we got it down to a second degree. Now, if this thing factors, that's great. That gives me my other 2 roots. If it doesn't factor, like this doesn't, I'm going to use quadratic formula. You should know quadratic formula. You should have quadratic formula memorized. If you don't, shame on you. Okay, so here we go. You should know this. A is 1, B is -2, C is 5. I'm just putting it in the quadratic formula. X is opposite of B, so regular 2, plus or minus square root of B squared, which is -2 squared, minus 4AC, 4 times 1 times 5, all over 2A, 2 times 1. So X is 2 plus or minus square root of 4 minus 20 over 2. That's going to be 2 plus or minus square root -16 over 2. You say, oh my gosh, square root -16. Oh my gosh, gouge out the i's. It's going to be 4i, right? Square root -16 is 4i. So now we get, I'll bring it over here. Now we get 2 plus or minus 4i over 2. Everything, some people stop at this point and say it's done, but it's not. It needs to be simplified. Look, everything has a 2, so make sure you do this. Make sure you factor it out. 1 plus or minus 2i. That's what I get if I pull 2 out of those guys, over 2. Now these cancel, and I get 1 plus or minus 2i. There is my other 2 roots. 1 plus 2i is a root, and 1 minus 2i. That's 2 roots. And then, of course, the -2 we originally had. So here is how the book would put the answer. They put the brackets, and then they list the 1 root you already know, -2, and then these guys, 1 plus or minus 2i. There is the solution set for that equation, -2 and 1 plus or minus 2i. That's how it works. Bless you. Bless you. God bless you. Okay. Now, let's see. This thing. Anyways, moving on. Okay. Same idea, kind of. Except for we're going to step it up a notch. So, here we go. This one. Same idea. Solve, except for, notice, this is a 4th degree. 2x to the 4th plus 3x to the 3rd minus 33x squared minus 22x plus 120 equals 0, right? That polynomial, given that 3 and -5/2 are roots. So I'm going to put 3 and -5/2 are roots. Okay. Now, we just learned how to do a problem similar to this on this one over here. Now, we're going to do the same idea. So if these guys are both roots of this guy, then guess what? If I take one of them out, I should get what for a remainder? Think. What should I get for my remainder if I do synthetic division with, say, 3 and this guy? Well, the remainder should be 0, right? Because it's supposed to go evenly. So we get 2x to the 4th, 3x to the 3rd, minus 33x squared, minus 22x, 120. Okay. Now, if everything goes right, if I copied it right and I didn't make any mistakes and everything, then this should end up being 0. Let's find out if it does. Okay, so bring down the 2. 2 times 3 is 6. This and this is 9, 27. Negative 33 and 27 is negative 6, negative 6. This and this is negative 18. That's going to be 10, carry the 1, 2, 3, 40, negative 40. Oh, I was getting worried, but look, negative 40 times 3 is negative 120, 0. Cha-ching! Yes! 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 Okay, so there we go. So that is good news. Now, here's where we got to pay attention to something, okay? So that's what we did on this other problem. Same idea, we got 0. And if I did this, I'd go remainder, constant, first power, second power, third power. This would still be a third degree polynomial. It knocked it down from a fourth down to a third, okay? Now, here's the deal. This is where people go wrong on this problem, so pay attention to this. Pay attention to this. I could do this, okay? Negative 5/2 works, right? It's also going to be a root. So I should do negative 5/2 and I still should get a 0. So I could do this. Now, I'm not going to write it out, but I'll show you. I could do negative 5/2 and then I could go 2, 3, negative 33, negative 22, 120. And if I do that, I will go blah, blah, blah. I would get blah, blah, blah. I would get 0 there. And then I would be stuck. Because I would say, okay, wait a minute. I've got this third degree equation and this different third degree equation. 2 third degree equations that I have no idea what to do with now. I'm stuck. I can't go any further. That's the problem, okay? So here's what you want to do. So it's not wrong to take negative 5/2 and do this guy and get a 0 here. That will all work. The problem is it leaves you with a third degree here and a different third degree here, and you don't know what to do with the 2 third degrees independent of each other. So here is the smart thing that we want to do. Instead of using these numbers, because look, we already sucked the 3 out of this guy, and we knocked this polynomial down into this third degree polynomial, right? We took the 3 out, okay? So, if the negative 5/2 was in this guy to begin with, and we just took out the 3 right here, the negative 5/2 is still in there. It's still inside this guy. So what I could do is if I use this new improved set of third degree power numbers, it'll knock it down to a second degree, and I can solve any second degree equation by the quadratic formula or factoring or whatever, at least by the quadratic formula. So the idea is don't use this new improved set of third degree numbers. Do not go back to these numbers. It'll get you nowhere. You want to use this new improved set of numbers. So 2, 9, negative 6, negative 40. Now again, because it's a root, this should also give me 0 for an answer here. Let's see if it does. Okay, bring the 2 down below the line. 2 times that's negative 5. That and that is 4. Okay, 4 times 5/2, that's going to be 5 times 4 is 20/2, which is 10. And it's a negative in front of it. Oops, I put it there. 10. Negative 10 goes right there. And then negative 6 and negative 10 is negative 16. Negative 16 times negative 5/2. Notice, negative 16, negative 5/2. This cancels 1, 8, positive 40. Oh my gosh, positive 40, 0, cha-ching. Well, there you go. Now, this goes remainder, constant, first power, second power. So, here we go. No remainder, right? Constant, first power, second power. So this equation right here, actually I'll bring it over here. 2x squared plus 4x to the first power minus 16 equals 0. The other 2 roots are hiding inside of that guy. So what do I have to do? Well, hey, good fortune is with me. Look at this. 2, everything has a 2. So I can divide by 2. Oh yeah. So x squared plus 2x minus 8 equals 0. Now, wouldn't that be nice if that factors? If it doesn't, I could use quadratic formula, right? But let's see. Oh my gosh, can I think of two things that multiply to be 8 and subtract to be 2? Like, I don't know, 4 and 2. What do you think? 4 and 2. Different signs, bigger one plus, so the 4 is plus. So I get x is -4 and 2. These are the other two roots. So the entire solution set is going to be this. 3, -5/2, and these guys, -4 and 2. It doesn't really matter what order you put them in. Any order would be acceptable. Okay, so there you go. Okay, hang in there. We got one more problem, just like this one. It's going to be a 4th degree. I just want to do one more of these so you guys could see one more of these hammered into your head. So I'm going to erase this now. Here's going to be the new one. The final problem for today. Okay, solve this guy. 2x to the 4th power minus 7x to the 3rd minus 14x squared minus 20x plus 75 equals 0, and 5 3/2 are roots. Okay, so here we go. 5 3/2 are roots. So I'm not even going to write that whole problem up here. Just absorb that. I'm going to use those coefficients. 5 3/2 are roots. So let's start with 5. I'd rather start with the integer one than the fraction. You could do it in either order. Okay, now watch. It's 2x to the 4th minus 7x to the 3rd minus 14x squared minus 20x plus 75. Notice nothing was missing, so I didn't have to worry about the zeros. But if there were any missing terms, you got to put zeros in. Okay, so let's bring down the 2. Multiply, 2 times 5 is 10. Add those together, 3. Multiply 3 times 5, 15. -14 and 15 just is 1. 1 times 5 is 5. -20 and 5 is -15. This times this is -75, which is 0. Cha-ching, just like I wanted. Oh yeah, things are going my way. Look at that. Woohoo! Okay. Now, the other root was 3/2. 3/2 positive, right? So again, I could use these numbers right here. If I use these numbers, I will get 0. So it may seem to me like I'm on the right track if I do that, but I'm not, because this would be a 3rd degree I don't know what to do with. I'd get another 3rd degree I don't know what to do with. Do not do that. Make sure you use these new improved set of numbers right here. 2, 3, 1, -15. If you do that, it still should give you a 0 there. Let's see if it does. Okay, bring down the 2. 2 times 3/2, right? The 2 upstairs and 2 downstairs cancel, give you 3. 3 plus 3 is 6. 6 times 3/2 is going to be 6 times 18/2, which is 9. 1 and 9 is 10. 10 times 3 is 30/2, which is 15. This and this is 0. Cha-ching. Oh my gosh, people, we're getting there. We're getting there. Okay, so we got remainder, constant, 1st power, 2nd power. So 2x to the 2nd power plus 6x to the 1st power plus 10 equals 0. No remainder, right? The other two roots are hiding inside of that guy. Wait a minute. Everything has a 2, so I can divide by 2. X squared plus 3x plus 5 equals 0. And can I think of two things that multiply to be 5 and add to be 3? No, just 5 and 1 is all I got, and that doesn't work. So I'm going to have to use quadratic formula. I could do completing the square, but I like using quadratic formula. So that's what we're going to do. A is 1, B is 3, C is 5. Let's put them in the quadratic formula. So here we go. It's going to be x is opposite of b. So -3 plus or minus square root of b squared, which is 3 squared, minus 4ac. 4 times 1 times 5 all over 2a, 2 times 1. That's going to be negative 3 plus or minus square root of 9 minus 20 over 2. That's going to be negative 3 plus root negative 11 over 2. Oh my gosh, look, root negative 11, gouge out the eyes, don't compromise. So you get negative 3 plus or minus I root 11 over 2. And so these are the other two roots. This really means negative 3 plus I root 11 over 2, negative 3 minus I root 11 over 2. So the answer is going to look like this. The two that they gave you already, 5 and 3/2, those are two of the solutions, and negative 3 plus or minus I root 11 over 2. There's two other roots, right? Negative 3 plus I root 11 over 2, negative 3 minus I root 11 over 2. Notice four answers to a fourth degree polynomial up there, fourth degree polynomial. That's how it works. So those are going to be like the problems on tonight's homework. Enjoy. We're going to spend 2 times on this. The next time we're going to stay on the same section because there's a lot of information coming your way for this. So have a good one.